Good day, my dear students, and welcome back here again in our chemistry class. And for today's video, I'll be discussing properties of matter. So when you say matter, matter is anything that occupies space and has mass. So generally, the properties of matter can be mass, weight, volume, or density. So when you say mass, it's the amount of matter in an object. The more matter is present in an object means the greater its mass. Now, it's usually expressed in grams or kilograms. For the familiarity of the unit of measurements, we use G for grams and kg for the kilograms. Now, the materials that are compact have relatively greater mass than those with a hollow interior. For example, on the picture on the right, which one has more mass between a block of wood and a ball? So definitely, the more compact material here is the block of wood, comparing to a ball which is more on hollow interior. So if you're going to recall about the different state of matter, we have the solid, liquid, and gas. For the weight, it is the measure of force that acts on an object. It is expressed as the amount of matter multiplied by the gravitational force that acts on it. The greater the gravitational force that acts on an object, the heavier it weighs. Now, it is expressed in Newton, and if we're going to be familiar with the units of measurement, we use N as a representation for Newton. For volume, it is the amount of space occupied by matter. It can be measured by using instrument, with graduations, or by getting the dimensions of the object. It is expressed in liters for liquids, or cubic length, or L cube for solids. So again, with the familiarity of the units of measurement, we use capital L for liters as a representation for liquids, and small letter of L with a power of 3 to represent for cubic length, which we use it for solid. For density, it is the ratio between mass and volume. It is expressed in kilograms per cubic meter, or kg per m cube, or grams per cubic centimeter, or we use g per cm cube. Now this tells us how compact an object. So an object with greater mass has more compact particles than the lighter ones. Definitely divide mass to its volume. For the general properties of matter, we have here the physical properties. For the physical properties, the qualities that are readily observable or measurable without changing the matter's composition. So generally, those quantities or qualities rather that are observable, we tend to use that in observing mass, volume, weight, or density. For example, on this one, we have the melting point, boiling point, freezing point, solubility, metallic properties, size, texture, shape, and color. Let's go with the melting point. So when you say melting point, it's a temperature at which solid matter changes to liquid. It varies according to its composition of materials. So this is just an example or representation of using my ice cream. So we tend to buy an ice cream and then we observe, right? If we're going to hold that ice cream and then suddenly melted, or you expose it into the heat, okay, it turns into a liquid form. That's the melting point. For the freezing point, is a temperature at which a liquid turns into a solid matter. So most likely, liquid to solid in a state of matter. So for example, here we have water freezing into snowflakes. Other examples that we can apply on the freezing point, if you're going to freeze water for you to have an ice that you may use to put it on your drinks. For the boiling point, is a temperature at which liquid evaporates. For example, the formation of bubbles in a heated liquid indicates that it's starting to boil. So definitely, anything that involving liquid to gas. So in a boiling point, the liquid evaporates. It turns into a gaseous state of matter. For solubility, it is the ability of a solute to dissolve in a given solvent. It varies depending on its composition. So it is considered as a physical properties as one can tell whether a matter is soluble or not by merely observing its physical appearance. For example, a spoonful of a sugar is soluble in water. It means it dissolves. Another thing is that when you make a drink, a coffee, such as 3-in-1 coffee or a black coffee or any chocolate drink that you try to dissolve it onto a solvent. So you have your coffee mix and then you have a water and you try to dissolve it. Definitely that is solubility. So we have here three metallic properties such as conductivity, malleability, and ductility. For the conductivity is the ability of a material to allow heat or electrical charges to pass through easily. Materials can be thermal or electrical conductors. So most likely in our real life examples here, we have the copper wire and the aluminum pot. So malleability is the ability of a material to be flattened into thin sheets. It means that compressive stress, hammering, or pressing. Now, ductility is the material or ability to be easily drawn into wires such as tensile, stress, stretching, or pulling. So the difference between the malleability, they have undergo into different stress. So in malleability, again, more on compression, and for the ductility, more on tensile. It means being pulled or stretch the material. For example, here in a gold ring, so if you're going to form definitely this kind of design, you have to press it definitely to get the right size of your ring finger. Then to have this kind of design of twisted, like a twisted knot. So it undergoes a ductility. So it has to be pulled or stretched. Now, please take note that qualities that are readily observable or measurable without changing the matter composition are known as physical properties. Another to add note to this one, always remember that in the physical properties, that is should be always observable. It can be seen that there is changes. In addition to physical properties of matter, under the physical properties of matter, definitely they are classified, it's either intensive or extensive. So basically, they're based on whether a physical property depends on the amount of matter or not. So in intensive properties, definitely they do not depend. So the examples can be color, density, boiling point, melting, or freezing point. If we're going to observe on the right picture, sugar remains white regardless of its amount or size. So it's either you put 1 to 3 cubes or 1 big cubes of sugar or 3 small cubes of sugar. So regardless of its amount. For extensive, definitely it depends on the amount of matter, such as its mass and volume. Now, if you're going to observe again this right picture, powdered sugar takes up more space than sugar cubes. So definitely, if you're going to break down these sugar cubes, it will take up more spaces on a jar comparing to a sugar cubes, which defines as intensive properties. Now let's move to the chemical properties. So when you say chemical properties, these are the characteristics that can only be seen when the chemical identity of a material is altered. So this become evident when a material undergoes a chemical change. So this highly depends on its composition. So the examples can be biodegradability, combustibility, flammability, and reactivity. In biodegradability, it is the capacity of a material to decompose through the actions of microorganisms. So it is Observe when a material undergoes a decomposition, for example, to an organic materials or carbon-based materials have a higher biodegradability compared to the synthetic ones. Now, if you observe these examples, it shows the approximate time for common materials to decompose in marine and terrestrial environments. We have here on the left side the materials which have the paper towel, apple core, tin cans, aluminum cans, and the plastic bags. On the middle, which shows the timeline to decompose. They are classified as marine environment and terrestrial environment. So if you observe in the marine environment, for example, in a paper towel, definitely they'll be dissolved up to 2 to 4 weeks. In a terrestrial environment, they'll be decomposed about 1 to 2 weeks. For the apple core, 2 months in the marine environment. And for the terrestrial environment, that's 4 to 6 weeks. For tin cans, that's for about 50 to 100 years, both environment. For the aluminum cans, we have the 200 years in marine environment, 80 to 100 years for the terrestrial environment. And lastly, for the plastic bags, it took 500 years to forever. Now, for defining definition of this marine environment, terrestrial environment, definitely when you say marine environment, definitely uh, examples for the sea. If these materials goes onto the sea, so this is the timeline they will be decomposed. Now, if one of these materials are exposed in a terrestrial environment or on the land, definitely here is the timeline. This shows how long they will be decomposed. For combustibility, it is the ability of a material to combust or burn. For the flammability, it's the ability of a combustible material to catch flame easily. One of the examples for the combustibility, such as wood logs, coal, diesel fuel, plastic, or fabric. So these materials can burn but may require higher temperature or longer exposure to flame. For the flammability, examples on this one is gasoline, alcohol, paper, dry wood, or propane gas. So these materials ignite easily at normal temperatures. So you can easily identify those materials that requires higher temperature before they burn and those materials that can be burned in a normal temperature. In reactivity, it is a tendency of a substance to undergo a chemical reaction. So this depends on the chemical structure and composition of substance, such as fluorine, which is most reactive element, and noble gases, which has no to little reactivity. On the right side here, the picture that we have an example, we have the platinum, which is one of the least reactive metals. Please take note that in characteristic of the chemical properties, it can only be seen when the chemical identity of a material is altered. This can be known as chemical properties. To sum it up, the characteristics of matter that are present to all kinds of matter are known as general properties of matter. The qualities are readily observable or measurable without changing matters. This can be composition or known as physical properties. Under the physical properties, they are classified as either intensive properties, which do not depend on the amount of matter, and for the extensive properties, definitely these are properties that depend on the amount of matter. The characteristics that can only be seen when the chemical identity of a material is altered are known as chemical properties. So, these two properties, the physical and chemical properties, they both have the different way of defining them. So again, for the physical properties, it must be readily observable. And for the chemical properties, any chemical or materials that being altered. And that will be all. Thank you so much for attending this chemistry class. And if you have a question, you may take a pause or take a screenshot of one of these frames and you can message me directly. So thank you so much and see you on the next video.